In this lesson, we will explore the fundamental concepts of data structures and algorithms.
Single linked list. So let's get started. Let us suppose we already have this list and head pointer is pointing to the first node of this list. Now we want to delete this particular node of this list. For this purpose, we need to create a pointer temp which must point to the first node of this list, and we have to move our head pointer towards right so that it can point to this particular node of this list. Now why this step is required? Because here we can see that this node has to be deleted, and if head is still pointing to this node, then it does not make any sense, right? Here the head pointer must point to the second node of the list, because after deleting this node becomes the first node of this list. That is why head pointer must always point to this node after deleting this node. And temp pointer is required because here we want to free the memory for this node. That is why there is a requirement of some pointer which must point to this node so that we can delete this node. So temp is required for that purpose. After deleting this node, the resultant linked list looks like this. So here is a program which helps us in deleting the first node of the list, and here I'm assuming that this list is already available with us. Okay, here in the main function I'm not writing the code for creating this list. I'm assuming here that the list is already available with us, and I'm just going to call this ∇first function, which is used to delete the first node of the list. And here is how this function looks like. You can see here that in ∇first function we are passing the head pointer, and this head pointer will receive the address contained in this head which is available in the main function. Now let's see how this function works. Here, because head has received this address 1000, therefore this head will also point to the first node of this list. In this if construct, we are checking this condition: is head equal to null? That means we are checking is list is already empty. If list is already empty, then we will print this message: list is already empty. There is no need to delete any element because list is already empty, right? That is why we will print this message. Else, we will do this procedure. That is, we will create a temp pointer which will point to the first node of this list. And then after that, we'll move our head pointer towards right, and then we will free the memory of this node. That is, we will delete this node. And you can see over here, the temp still contains this address 1000, which is the address of invalid memory location because we have deleted the memory for our node. That is why we must assign null to temp, and then finally we will return head. And here in main function, head will receive this address 2000 because we have returned that head in the ∇first function, right? Here this head will receive this address 2000, and it is very important to receive this address because here in the main function, changes will not get reflected if we didn't receive this address. Here in the main function, if we didn't receive the address 2000, then head will still contain the address 1000, which is wrong. It is important to assign this address to head so that it can point to the new node of this list. After this, I'm assuming that PTR is already created in this function. That is, I have declared PTR pointer already in this main function. I'm assuming at this point in time. This means I can assign head to PTR, which means PTR is also pointing to this node. And after that, I will use this while loop to print all the elements of this list. That is 98 and 3. Okay friends, this is it for now. Thank you for watching this